Welcome back, everybody. In this video, we're going to go through lessons 8 and 9 of Unit 2. And what lessons 8 and 9 have to do with is something called end behavior. End behavior. And what end behavior is what happens to a polynomial as x gets infinitely positive and infinitely negative. So in other words, as x gets really, really large, what happens to the y values? Do the y values go up or do the y values go down? And as x gets really, really small, so like negative a million, negative a trillion, so on and so forth, what happens to the y values? Do the y values get really large? So do they go up or do they get really small? Do they go down? And this kind of sums up, this table here sums up everything you need to know about finding the end behavior of a polynomial without actually graphing it. It turns out in order to figure out the end behavior, all you need to know are two things. You need to know the degree, whether it's even or odd. And remember, the degree is the largest exponent. So the degree, whether it's even or odd, will help you determine the end behavior. And the leading coefficient, whether it's positive or negative, will also help you determine the end behavior. So the leading coefficient, remember, is the coefficient of the term with the largest exponent. So depending on whether that's positive or negative will depend on the end behavior. So again, it turns out if you know the degree and you know the leading coefficient, you can figure out the end behavior. Now, to show you how this table works, let's go ahead and take a look at the examples. So I have three polynomials here. Okay. Let's go ahead and find the end behavior. So the first thing we need to do is we need to find the degree and we need to find the leading coefficient. Okay. So let's look at number one. Let me zoom in on number one. Number one is x squared minus 2x plus 8. So the degree is the largest exponent. Now the largest exponent I see is x squared. So my degree in this case is going to be 2. And my leading coefficient is going to be the coefficient of that term. Whatever term contains the largest exponent, the leading coefficient, the coefficient of that term is what we call the leading coefficient. So in this case, this is a 1x squared, so the leading coefficient is 1. So I have a degree of 2, and I have a leading coefficient of 1. So a degree of 2, that's going to be an even degree. Leading coefficient of 1 is positive. So I have a even degree and a positive leading coefficient. And if I put that together, then this right here is my end behavior. So we would say that the end behavior is up. The way we would describe it is up to the left and up to the right. So up to the left and up to the right. That's what that picture means. And it turns out if we actually take a look at the graph, so I'm going to go to Desmos real quick and actually graph this. So x squared minus 2x plus 8. So x squared minus 2x plus 8. If I take a look at the graph, as I zoom out, you can see it goes up to the left and up to the right. That is the end behavior. The end behavior does not tell me what happens in between. It tells me what happens on the ends. So it goes up to the left and up to the right. Okay? Let's take a look at number 2. So number 2, we have here 2x to the fifth minus 5x to the fourth minus 30x cubed plus 5x squared plus 88x plus 60. So what is my degree here? What is my largest exponent? My largest exponent is going to be 5, x to the fifth. Okay? And then the leading coefficient is going to be the coefficient of that term. So it's 2x to the fifth. So the leading coefficient is 2. So I have a degree of 5 and a leading coefficient of 2. So on the table, a degree of 5, that is an odd degree. A leading coefficient of 2, that's a positive leading coefficient. So I have an odd degree and a positive leading coefficient. So this right here describes my end behavior. So you can see the end behavior is down to the left and up to the right. So my end behavior would be down to the left and up to the right. Down to the left and up to the right. Okay? That is all we have to do. So on number 3, let's do number 3 now. So we have to do our degree and our leading coefficient again. So negative 20x to the fourth plus 3x plus 8. So this term has my largest exponent. So my largest exponent is going to be 4, so my degree is 4. And my leading coefficient is going to be negative 20. So I have my degree and my leading coefficient. And if I use the table, a degree of 4, so 4 is an even number. So that gives me an even degree. So an even degree and a leading coefficient of negative 20. So that's a negative leading coefficient. So I have an even degree and a negative leading coefficient. So this right here is going to be my end behavior. So my end behavior would be down to the left and down to the right. Down to the left and down to the right. And just to check it, let's go on Desmos and actually graph number 3. So again, it's negative 20x to the fourth plus 3x plus 8. So negative 20x to the power of 4 plus 3x plus 8. So we can see it goes and does indeed go down to the left and down to the right. Once again, let me reiterate what I said before. The end behavior does not tell me what happens in between, so it's not going to help me with how things go here. It's only going to help me with the bookends. What does it do as x gets really, really small, and what happens as x gets really, really large? And it turns out in both cases, in this case, y goes down to the left and down to the right. So that is end behavior, and that is it for lessons 8 and 9.